Hello, everybody. Mr. Mercury here, and we are about to start on a brand new unit, which is all about this new shape that you guys undoubtedly have seen in your lives and in the real world. And what we're going to do is, well, basically take a magnifying glass to it and just really study it and see what we can learn from this new shape here. So you can see that I've got this YouTube video up. Certainly looks like it's about basketball. And this is where I'd like to start today. So let's take a look at, let's watch a little bit of this video. And I'd like to talk about why what we're doing today is actually pretty important and what that means for us for the rest of the unit here. So here we go. Let's take a look. The music is a little dramatic. I will say that. Okay, so I'm going to pause it right there and say that those were like literal game clips, obviously. What we're going to do is take a close look at this shape that the basketball made when it was being thrown. And this shape has a funny name. It's something called a parabola. And what we're essentially going to do for this whole next unit, actually for the next two units, in trimester 2 and in trimester 3, is we're going to look at what parabolas are, what they do, and what they can tell us in lots of different situations. So right here, I paused it to add a little bit of this video clip of this person, his name is Dan, shooting a basketball into a hoop. You can see already the basketball is at maybe the top of its trajectory right here. And the question that I would ask, usually when this is paused at this point, is, will the basketball make it in? So I want you to take a second and think to yourself, will this basketball make it into the hoop? Okay, well, there's one way to find out. Let's let it play and let's see if it makes it into the hoop. Okay, so that one didn't quite do it. So one thing that you might notice is that we see the shape right here with these awesome freeze frames of the basketball. You can see that this shape, which sort of looks like a wide U almost, it's got like a point at the top. And then what it is, it's the same on both sides, right? If the basketball is going up on this side, it's going to go down in the same way on the other side. And we call this symmetric. So this shape here, which is called a parabola, it has like a highest point or a lowest point that we'll see too, and it's symmetric. So let's watch a couple more and let's see if you can predict whether the ball is going to make it in the hoop. Okay, so what do you think? Is the ball going to make it through the hoop here? We see about half the parabola. What do you think? Okay, my guess personally is I'm going to say no. I think this parabola looks a little too skinny, but we'll find out. Oh, okay, so it looks like that one, we weren't seeing the whole parabola. So maybe right here, we pause at the top and we see that if we were to continue it into there, it looks like it's going to make it into the hoop. Let's look at the next one. Okay, so here I've paused it at maybe a little more information, which is good. So let's make a brief prediction. Will this ball make it into the hoop? Okay, if you said no, you're probably right. It looks like this parabola is too skinny. I thought the last one was too skinny, but it looks like this one definitely is. This one's going to be symmetric, just like all the other parabolas. So I should see the basketball do the same sort of curve on the other side as I am looking at on the left. So I'm expecting it to kind of follow this right here and just completely miss the hoop. I think we call that an air ball. So let's take a look. Yep, looks like I need to clear that. Okay, there we go. Yep. Okay. What about this one? Is this ball going to make it through the hoop? Some people might say yes. Some people might say no. You might be thinking it's going to bounce off the backboard, go into the hoop, but let's find out. Okay, it looks like it did that. This one looks like it's pretty safe to go into the hoop. Oh, okay, didn't quite hit it right. This one looks like it might go in. Perfect. Awesome. So this idea of using a shape in math to predict what's going to happen That's going to be a big theme of what we're going to end up seeing later on in this unit when we get really proficient with parabolas and how we use their equations and how we talk about the different parts of a parabola and what that means. This obviously isn't, well, if I would be lying if I told you that basketball players use parabolas to predict where their ball is going to be. Like, no one does math when they shoot a basketball to try to find out if the ball is going to make it in the hoop or not. No one does that. It's like all intuition, right? But scientists can predict things like this when they are studying parabolas in other contexts. Like, let's say, for example, that you're not shooting a basketball. Let's say that you're firing a rocket or something like that, and you've got one shot. You better make sure that that one shot is going to achieve your goal here. So you're going to make all the computations and calculations that you can at first. And we'll make sure that that happens. And we're going to be seeing problems later on in the unit and also a little bit right now that help us see where parabolas come into our lives. So let's grab our note packets and let's take a look. Okay, so welcome back. This is what we're taking a look at today. We're not really doing a whole lot of heavy math. All we're doing is just getting used to this shape of what a parabola is and what are the parts of a parabola. So what I'd like you guys to write down here in the warm-up spot is this equation, ax squared plus bx plus c. This equation is called a quadratic. And when we graph a quadratic, we get either that shape or that shape. They're the same, just upside down. And these shapes are called parabolas. So parabolas, when graphed, quadratics, when graphed, make parabolas, and parabolas, when written as equations, make quadratics. So two little pieces of vocabulary words today. We're going to be taking a look at the anatomy of a parabola, which means we're going to be looking at the parts of a parabola and labeling those parts and just being able to talk about what those parts are. Okay, so here's our vocabulary list, and we're going to have a few more things that we'll talk about in here as well. What I'd like you guys to do first is I want you to make sort of a big y-axis like this, and also an x-axis like that. And I'm going to draw a red parabola on this graph. I'm really good at drawing parabolas, so let me show you. Draw a shape like this. This is what we call a parabola. And actually, I want to do it a little differently here. Let's make the y-intercept just a smidge different. Okay, there we go. Slightly different parabola, but you get the picture here. So we've got a U-ish shape, and this is called a parabola. And we're going to talk about the different parts of the parabola right now. So let's run through this vocabulary. So a quadratic function takes the form y equals ax squared plus bx plus c. And we're going to see this more and more over the next few days, but for today, we don't have to worry about it too much. I think I'm going to ask you questions about this first thing, but we'll make sure that we talk about that. It's not as bad as you might think. And then the parent function, if we take away all the extra stuff, so ax squared plus bx plus c really comes from this simple function y equals x squared. And we're going to see what the graph of y equals x squared looks like probably next time in class, and what that means for what parabolas do. Okay, so the word parabola, like we talked about, is this shape right here. And parabolas that we'll be working with at least either open up or parabolas open down. So a parabola can either open up or open down. So open up means that the parabola points upward like this, and open down means that the parabola is kind of opening downward. So let's talk about a little connection to this equation, this quadratic right here. A parabola will open up if ax squared is positive, and the parabola will open down if the ax squared term has a negative on it. So this is going to be important when we start graphing these by hand, but I want you to start thinking about that now. So for example, if I wrote the equation y equals 2x squared minus 3x plus 5, this is the kind of thing we'll be graphing in a few days here. I look at the 2x squared, I see that's a positive number. So this parabola, even though I don't know anything else about it, when graphed, this parabola would open up because the 2x squared right here is positive. Okay. So that's a little bit about the shape of parabolas. Let's identify some parts of parabolas. So the first thing that we're going to identify is this point called the vertex. So the vertex is the point either right at the bottom or right at the top of a parabola. So it's the point at either we call it the maximum or minimum of the parabola. So this is the vertex right here. And it's going to have some kind of a coordinate to it, like x comma y. So this is the vertex. This particular vertex is a minimum because it's the smallest point, the lowest point on the parabola. If the parabola were opening down instead, this point, the vertex, would be a maximum. Okay, let's talk about the axis of symmetry. So we talked about briefly how parabolas are symmetric, like they're the same on one side as they are on the other, and that that line that kind of divides them into two symmetric sides is called the axis of symmetry. Let's draw a purple line for that right here. Okay, so there we go. So this purple line right there is the axis of symmetry. So the axis of symmetry is the line that divides a parabola in half. Okay. I should say something else about the axis of symmetry. The axis of symmetry also has a particular form that we write it in. It's always going to look like x equals and then some number right there. So you might remember that lines that look like x equals are vertical lines. And that's what the equation for the axis is going to be. It's going to be a vertical line that looks like x equals something. So whatever the x coordinate is right there, that's going to be the equation that the axis of symmetry depends on. All right. So the last two definitions here are the domain and the range. So the domain, what that's going to be is all the x's covered by the parabola and in this particular graph right here, if we look at the x-axis, this parabola is going all the way to the left and all the way to the right. So all of the x's are covered on either side, no matter what. It might look like the parabola stops right here, but in reality, as it goes up, it keeps going to the left. As it goes up over here, it keeps going to the right. So the domain is always going to be, we say, all real numbers. So all the numbers for a parabola are part of the domain. If you want a cool symbol that means that, you just use a little r with a double slash through it, or like a double spine almost. And then the range of the parabola is all the y's covered by the parabola. So if we want to describe the range, then we might say something like all the y's that are greater than or equal to the minimum. So we'd look at the vertex here, we'd see what the minimum y value is, and we'd say, okay, the parabola has all the y coordinates that are above that. And if the parabola opens down, we might say that it's all the y values that are below the maximum. So that's what the domain and range are kind of going to be used for in a parabola. We also have a few other things in the parabola, stuff that you know from when we did lines. So we have this point right here. This point is called the y-intercept. You might have known that from before. But then we also sometimes in parabolas, we have these things called x-intercepts. And a parabola doesn't always have two x-intercepts. Sometimes a parabola has one x-intercept. Sometimes a parabola has no x-intercepts. It depends on where it is. Imagine, for example, that we took this parabola and we moved this red parabola up so that it was above the x-axis, but still facing up. Well, then this parabola, maybe it looks like that, wouldn't have any x-intercepts because it doesn't intersect the x-axis at all. But it would still intersect the y-axis, so it would have a y-intercept. I could also maybe draw a parabola that just barely touches the x-axis like that, and maybe has only one x-intercept. Okay. So those are all the vocabulary words that we'd want you guys to be able to identify off of parabolas. What I'd like us to do now is take a look at just a couple examples here. And really, the name of the game today is just the anatomy of the parabola. Sorry, that's my cat. He's concerned about something. So we're going to take a look at these parabolas and we're just identify all of the different parts of them. So we're going to identify the vertex of each graph, tell whether it's a minimum or a maximum. What's the equation for the axis of symmetry? We're going to find the domain and range. Let's take a look at A. So we're just going to look at this graph and tell what the vertex is. Well, in this case, the vertex is this point right there. It's the point at the top of the parabola. So right away, I can say that because this is at the top, this vertex is a maximum. And then the point that this vertex is at looks like the x-coordinate is -1 and the y-coordinate is 4. So I'm going to write -1, 4, and it's a maximum. I can also tell that this parabola, well, I might ask you that. Does this parabola open up or does this parabola open down? Okay. If you said opens down, you're right. So this parabola opens down. So that means that the ax squared in the parabola equation would be negative. Okay. So let's talk about the axis of symmetry. So the axis of symmetry is this line that sort of cuts the parabola in half. It's the thing that cuts it right in half, same on both sides. And this axis of symmetry goes through the x-coordinate -1. So its equation would be x equals -1. And you can see that the axis of symmetry has the same x-coordinate as the vertex because the vertex will always be on the axis of symmetry. Notice that the vertex is always sort of like in the middle of the parabola, just on the top or bottom. So it's in the same x-coordinate as the axis. Okay. And then last thing, what we'll do is we'll just find the domain and the range. I think we might also find the intercepts also. So the domain and range, the domain is actually not that hard for each and every parabola. Every single parabola has this as its domain. They all cover all of the x coordinates. This parabola is going to the left, so all of these over here are going to be covered. This parabola keeps going to the right, so all of these are going to be covered. And this parabola has all of the other x coordinates in between. So the domain for a parabola will always be all real numbers. So all of the x's are on the graph of the parabola. If I wanted to find the point in the parabola at x equals 4, x equals 4 is over here. So that's if I keep on following this parabola over, x equals 4 might be way down here, but it's still on the graph somewhere. The range of this parabola has to do with the y values, so we'll take a look at the y's. So if I look at this parabola, I see that the biggest y value is 4. So 4 is my biggest y value, and then all of the other y values on the parabola are less than 4. So what I'm going to write is y is less than or equal to 4, and that's what our range is. I also mentioned y-intercept and x-intercept, so let's just talk about that. The y-intercept of this parabola, well, that would be this point right here. So it looks like y equals 3. And then the x-intercept of this parabola looks like it has, it's got 1. Does it have another one? Yeah, I see it over here. So it looks like our x-intercepts are x equals 1 and x equals -3. So if we count them over, 1, 2, -3. Yep. Okay, so that's all the parts of this parabola and essentially what we're looking for. So why don't you try that over here? So in example B, I want you to try finding the vertex, label whether it's a max or min, tell whether the parabola opens up or down, the axis of symmetry, and then if you're feeling spicy, you can try the domain, the range, and the y-intercept, and any x-intercepts if there are x-intercepts. So why don't you pause the video and give that a shot? Do you think you can find those in this parabola? Okay, so let's take a look here. So this vertex is this spot on the parabola. That looks like we've got -2, comma, -3. So we're going left 2 and down 3. Yep, so -2, -3. Is this parabola max or a min? Well, it looks like it's the slowest point on a parabola. So I would call this vertex a minimum. So that's the minimum value of the parabola, the lowest the parabola goes. How does this parabola open? Well, this parabola opens upward. It's like an upward facing bowl. So that means that the ax squared is positive. The axis of symmetry, so that's going to be the line that goes right up the middle of the parabola. And we write that as an equation, x equals something. And what's the x coordinate that this line goes through? Well, it goes through x equals -2, which happens to be the same as the vertex. Maybe you tried the domain and the range. So the domain here would be all real numbers. All parabolas always have a domain of all real numbers because the parabola keeps going to the left, keeps going to the right. So all of the x coordinates are covered no matter what. The range is a little tougher. So here for the range, we look at the y values. Let's look at the y values here. Does this parabola have all y values? Well, looks like it gets its lowest y value here at -3 on the vertex. So -3 is my lowest. And then looks like it has all the y values that are above -3 from there. You can see that this parabola has y values that are above this -3. So we're going to write all the y's that are greater than or equal to -3. You can kind of see that opens up means that our range is going to be y is greater than, but opens down means that our range is going to look like y is less than. Because if the parabola is going down, all the y's are going to be less than a certain amount. But if the parabola opens up, all the y values will be greater than a certain amount. And then the y-intercept here looks like this point intersecting the y-axis, so y equals 1. And the x-intercepts are harder to tell. We can kind of estimate them though. Looks like it might be x equals -1/4 or 0.25. So -0.25. And the other one looks like it would be x equals -3.75. And I think that fraction would be, I think it would be 15/4, -15/4. Okay, so your foundations formative and your core practice today are all going to be about finding the parts of a parabola and labeling what they are and just knowing what they are. Basically just dissecting parabolas. We're not really going to be solving any equations or actually doing graphing today. We're just trying to get to know this new shape and all the different parts of it to prepare us for how we're going to use it later on. Okay. If you got any questions, feel free to ask me or your teacher, and Ms. Fuller, Freddie, or Ms. Bennett. And if you guys, well, hit a rough spot, make sure you do that. Have a good day. I will see you later. Bye.